Thank you. Well, you've all seen my slides now, so I can just go, right? So, I was a bit worried when I saw Asim playing with my laptop throughout that. Why is it not coming up? Okay. So this is my third year at nullcon, and surprisingly they keep asking me back, so thank you. It's the first year I've actually been asked to give a talk. I think I've only done training here, right? I've never spoken. And you know what it's like when you first do something for someone, you don't want it to be the most difficult thing that they can ask you to do. So they asked me to do the keynote, so no pressure, thanks, Antrix. I also really like the community spirit here. I've been part of community hacker conferences like DEFCON for over 20 years now. I run the London DEFCON group, so if any of you ever come to London, we're the last Tuesday of the month. You're welcome. It's open. It's in a pub, so we do a lot of drinking and talking, but mostly talking, obviously, because we're responsible hackers, right? And so I didn't have when I was asked to do the keynote, I didn't have a title for the talk. So someone asked me, what's the title? And we were sitting in the shack on the beach having dinner. So I was like, ooh, shack on the beach. And I'll just cross out the S because that's a really good pun. That's a hacker pun, right? So hack on the beach. So it's got nothing to do with beaches and it's got nothing to do with hacking on the beach. That was just something I had to put on the slide. They also asked me what T-shirt am I going to wear. I'm going to wear a DEFCON T-shirt or a nullcon T-shirt. As you can see, I'm wearing neither. I come from a really tiny village in the middle of nowhere in southern England. And one of my neighbors is a dairy farmer. And so he has a lot of cows and a lot, they make cheese. His family's been making cheese for about 300 years. And as a farmer, he's interested in, he has to get up early in the morning and he likes a drink because he's a farmer. And he likes to get up in the morning and not have a hangover. But he also likes free booze. So he's like, okay, I'm a farmer. I've got all these raw materials. I should be able to make my own booze, right? So he tried everything. He tried potatoes. He tried grain. He tried whatever to make vodka. And in the end, he realized his family business, which makes cheese, they have a byproduct when you make cheese, which is whey, which is normally, excuse me, is normally turned into animal feed. So he tried making vodka from that. And guess what? It's really good. So he now makes this stuff called black cow vodka, which is pure milk vodka. And since cows are sacred here, right? That's like holy water. So I thought this was appropriate to wear. And I have some with me, so if anyone wants a taste, come and have some holy water with me after the conference. So that's why I'm wearing this shirt. Okay, so what am I going to talk about? Well, when you give a keynote, you have to give some words of wisdom, right? I'm not sure there'll be words of wisdom, there'll be words, almost guarantee that. I'm going to talk about what's going to happen. I can see into the future. I know everything that's going to happen. And I get to say, I told you so. And of course, I will give you the winning lottery numbers too. Because I can. No, I have no idea what I was going to talk about when he asked me to do this. So I just thought I'd talk about, my experience. I've been a white hat hacker since the 80s. I did a lot of talks. I've done a series of talks called Old School Hacking because I realized a while ago I'm kind of getting old, I was at a conference and the speaker before me said, oh, it's so nice to see so many old timers here. I'm like, really? Oh, wait, I am old. So I prefer the term old school, not old timer, but basically I am an old timer. As I say, I've been doing this for a long time. So long, in fact, that when I started, we didn't have any of this stuff. How many people here have had mobile phones since they remember? Seriously, none of you? You're all as old as me? Wow. Okay, well, I can give up on this talk then. I thought I was going to be a room full of young people that didn't remember the time before the internet. So yeah, we didn't have all that when I started. Mobile phones were these big, clunky, portable brick things. Internet literally didn't exist. You had to dial into networks and so on. So yeah, we didn't have any of that. So we invented all that shit. Right? When I say we, I don't mean me, but you're welcome. The next generation. So how did I get into all this stuff? Well, I'm kind of an early adopter because I had to. So for work, not because I'm a fanboy and I go out and buy the latest Apple or I buy the latest Android. I didn't get into iPhones until about the third generation, I would say, because, you know, they weren't very good, the first ones. My Nokia actually worked a hell of a lot better than the first Apples. But when they got good, then I switched and started to need to use them because, you know, they start to become relevant to work. Same with Android. I mean, I think I switched from iPhone to Android on about the third or fourth generation devices when it actually started not being slow and clunky and crashing all the time. And I preferred Android because of the more open environment. So I'm a very much an open source guy. Pretty much everything I do, I publish if I can. So you'll find a lot of my work on GitHub. I've been, you know, giving talks for, as I say, about, well, not the full 20 years. In fact, in the early days at DEFCON, so in the opening slide, you'll see my name was Adam Major Malfunction Laurie. So I'm known at DEFCON as Major Malfunction. So that's my handle. And for the first probably 10 years of going to DEFCON, that was the only name people knew me by. Nobody knew my real name. And the reason for that was not because I was an evil hacker hiding and doing bad stuff, but because the world wasn't ready for us. White hat hackers wasn't a thing 20 years ago. Hackers were just hackers and bad guys. And so DEFCON did actually start as a kind of underground conference. You know, there was a bunch of, I think one of the audience who was talking about their experience said they like to come here because they meet people they don't normally get to meet, that they only have a virtual relationship with. And that's how DEFCON started. You know, when I first went to DEFCON, I think there were 60 people there. And it turned out I knew about half of them from online connections. So these were people I was meeting in bulletin boards. In those days, it was like FidoNet, and the internet was just starting. And so I had relationships with people all over the world, but only through email and only through chat forums and only through playing multi-user games together, which were very primitive in those days. It was just text-based stuff. And so I started going regularly to DEFCON. I wasn't speaking then. For the first 10 years, I got roped into being staff pretty much straight away. I think I had one DEFCON where I wasn't staff, which didn't actually used to matter in the early days because everything happened in one room. So even if you were working in the room where the talks were being given, so you actually got to see the talks. And I started on the network team, and then I migrated to, I created what I called jokingly QM stores, which is the quartermaster stores. And basically that was the cupboard in my bedroom at the hotel where I just put stuff that needed to be put away at night. And that grew and grew and grew and grew. And now I have a staff of 18. And we load in 6 full Arctic truckloads of equipment, I think 70 pallets stacked about 8 foot high each of gear. And that's what runs DEFCON now. So I'm busy. I'd sit in a room throughout the entire conference, never see any talks. But anyway, I will ramble, by the way. This is what I do when I get started. So for the first 10 years, I couldn't tell anyone my real name because I was afraid that if my customers in the UK heard that I was going to a hacker conference, then they wouldn't trust me anymore, and I would lose my clients, and my company would get in trouble for going to hacker conferences and so on. So literally for the first 10 years, I had to go in secret, kind of. Happily, that's all changed now. And I think, DEFCON is in a large way responsible for that. We had a lot of pushback from vendors originally. We would publish stuff and they would get upset and there would be lawsuits, and you guys are getting that now. And I guess this industry is fairly new over here, and so you're going through those same growing pains where the government and the industry don't understand that this is actually, there is such a thing as a white hat. There is a good reason why we should be hacking stuff, and actually it's for everyone's benefit in the long run. And it took a long time for the industry in the US and in the West to understand that, but they did in the end. And the big change came one year where Microsoft came along, and they said, well, we're going to release a new version this year, and every time we do it, you guys just hack the crap out of it. So rather than doing that, this time we're going to tell you in advance what our plans are, and please give us some feedback. And that changed everything. And then all the other vendors started doing the same, and they actually set up a security at Microsoft.com and so on. And that was all new in those days. So so I've seen it kind of evolve. And as I say, it looks like it's evolving similarly over here now. So basically, the reason I poke around in this stuff is because I need to use this stuff for work. I need the stuff to work and to actually be secure. So again, why are you hacking my product? Well, because you said it's secure and it isn't, and I need it to be. So I started life working for a database company. I was in the integration and support and distribution department. In fact, I ran it. And again, this is going so far back that machines didn't have any kind of standard. There was no standard floppy disk format that worked in every machine. So when we wanted to distribute our software on a different brand of PC, I had to figure out how to copy the data onto that particular PC's floppy disk format. And unbelievably, mag tapes. There was no such thing as a CD or a DVD. There were no USB sticks, no internet. We didn't even actually have wired networks in the really early days. So out of that spun off a business. So I realized a lot of our customers had the same problem. So people who were buying the software for the database also had other things they needed to move between these different systems. So on the side, I set up a media conversion business. And so after work at the database company, in the evenings, I would use that equipment to run my own business, moving data around for other companies. And then that split off into some vertical markets. So, again, this is all new stuff. People who are using computers for the first time in their businesses, if they come across someone who's providing a service, and we started to see a lot of desktop publishing data being moved around between these systems. So it was obvious to us, well, we should just spin off a desktop publishing company and start doing the same stuff. And even mag tape duplication. Again, this looks pretty old school, but those big half-inch tapes were still being used and needed to be duplicated and distributed and so on. And I got into batch printing. So you would get a database and you print off letters individually addressed and so on. Again, pretty everyday stuff these days, but then it was new. No one was doing it. Floppy disk duplication. So back in those days when you bought a computer magazine, there would be a floppy disk stuck on the front. and it would have the latest games or demos or whatever. And so my company was mass producing those. So we would get a master disc, and then we'd produce 50,000 or 100,000 copies of those discs, which was, yeah, a terrible idea in my office, because we actually were on the top floor of a building that just had a single man lift. And so we were constantly loading these, tens of thousands of floppy disks into this tiny little lift, taking them upstairs, duping them, taking them down again. It was a nightmare. But that led to CD mastering. So basically what happened with the magazines is they started putting so much content on that you would end up with 2 or 3 floppies on the front of every magazine in order to try and put as much as you could on there. And it was too much. So anyway, when CDs came along, I proposed to one of the magazine companies that we should actually put a CD on the front of the magazine. And in order to create that CD, I started working with a company called Nimbus Records, who are one of the first companies in the UK to produce CDs. And this is where it started to get really interesting, because in order to actually produce a CD that would be useful to enough people to make it worthwhile, we had to actually look at the low-level format of the CD and say, well, is it possible to produce a CD that if you stick it in a Windows machine, it's going to work, and if you stick it in a Mac, it's going to work? Again, this sounds fairly mundane now. It's a standard thing, but there was no standard at the time for doing that. So we had to get right down and dirty and start playing with the low-level data to figure out how to do that. And when I was doing that, talking to the guy at Nimbus Records, he basically said, he taught me how it all worked, and the low-level on a CD worked. How many of you know how a CD works? A few, getting a few nods. Okay. So it's like a record. You've got a spiral track on the CD, and the motor is variable speed. So that the data bits have to go past the head at the same speed, regardless of where on the disk you are. Now, obviously, if the disk was spinning at the same speed, the outer tracks are going to go by way faster than the inner tracks by the time you get out there. So the motor varies speed. And it does this because the track is not a perfect circle. It's actually wobbling the whole way. It's like a wavy line. And so the head has to do this in order to follow it. And it does that at a particular speed. And by maintaining that speed and varying the speed of the spin in order that that wobble stays at the same rate, you get your variable speed spin. So I was talking to this guy at Nimbus, and he explained all this. And I'm like, so what happens if we, halve the size of the dots that you're reading and double the speed of the wobble and just let the whole thing slow down? Could we get double the data on the CD? And he's like, I don't know, let's try it. So, he has all the equipment to produce this stuff. So we tried it, and the damn thing worked. And we tried it so he produced some music CDs, he produced some data CDs, and we tried it in every commercial CD player we could find on the market, and it just worked. So, I don't know if you remember, but, CDs were 60 minutes. But they could have been 120 minutes. Maybe they could have even been 180 minutes. And it was a big deal that you could only fit so much data on a CD, but nobody did anything with it. I don't know why. So we could have had double-sized CDs right from day one. The other thing I came across, which at the time was interesting, so read-write media had just come out, so burnable CDs. And there was a lot of stuff in the press about, are you going to do your backups to a burnable CD and then lose them? Because how long is it going to last, and so on. So there were all these tests and, published articles saying, oh yeah, we've tested it all, it lasts 10 years. So I actually did an experiment. I burned, I think, about a dozen CDs, and I just left them outdoors in the sunlight. So in a waterproof case, so it wasn't going to get wet, but just sitting in the sun. And then every week we would bring one in and we would try and read it, or we'd bring a bunch of them in, try and read them. And after about 6 weeks in direct sunlight, they started failing. Even though these reports basically said, no, they'll last 10 years. We've done these tests on the ink. It's going to last 10 years. But they had completely fudged the test. They basically did the testing on unused media. So if you take a blank disk that's never been used, yes, that ink will last 10 years. But the way a rewritable CD works is the laser actually breaks down the compound and changes its structure. So once you've actually written to the disk, then sunlight does affect it. So the whole rewritable CD industry was based on a total lie, basically. So anyway, playing with CDs led me to understand a lot about how stuff worked under the hood. And as C mentioned, I ended up writing the first CD ripper, which was called CD Grab. And I had a lot of discussions at the time with, knowledgeable people in the industry who said, well, it couldn't be done. You can't read data from a music CD. That's just not how it works. And, to me, that made no sense. I'm like, well, the whole point is it's digital data. So clearly, if there's digital data on this disk, I should be able to just get the bits and bytes off. So I had online arguments with some guys, and some guys from Sony said, no, it doesn't work like that. You can't do it. And then one of the CD manufacturers came along, the guys who made the CD drives for PCs, and said, well, we'd be really interested if you can get it working. So, here's some equipment, and here's the source code for our driver. And in those days, you had to load a shim under DOS called MSC-DEX, which was the CD sort of man-in-the-middle module for Windows, or for DOS, that allowed your software to talk to the CD drive. And when I looked at their source code, I realized that they were actually deliberately blocking. So there was a 1-bit setting which said this is a music disk or a data disk. And if it saw that bit was set for music disk, then it refused to pass any data. So literally I had to make a 1-bit change or 1-byte comparison change to the code to switch off that check, and bingo, it started sending me data. So I was able to produce software that could actually read raw audio directly from the disk. This was really back in the day, so before open source was a big thing, and I didn't understand the open source model, hadn't really heard of it. So we published it, and we gave away a free version that was kind of limited functionality, and then we charged like 50 quid for the real version that could rip more than 10 seconds worth of music, and you could use the free one to check that it actually worked, and then if it did, you buy the 50 quid version, you can rip the whole thing. At the time, the hard disk, a 600 meg hard disk, I think a CD cost £15, and a 600 meg hard disk cost about £300. So if you ripped a CD, you were going to fill up 300 quid's worth of hard disk with something you just bought for 15 quid. So it didn't really make a lot of sense. So not many people were using it. But one of the people who came and purchased it was building a satellite radio station. And they wanted to transmit raw, uncompressed audio. So they wanted to rip CDs and create a huge library of all the music they wanted to transmit. 64 channels of what's called Muzak. So basically it's being piped into commercial premises who want rock music or, country music or whatever, piped into their business. Anyone heard of QNX? A few of you. So QNX was awesome. It's the most amazing operating system. It's basically real-time Unix. So if you want to do anything real-time, you just ran it. It was just like normal Unix. There was nothing clever or fancy you had to do. It just prioritized everything to try and make it real-time. And it did it incredibly well. I think they were bought in the end by BlackBerry or RIM. I don't know what's happened to it since. Does anyone know? Is QNX still around? Yeah? Still awesome. I love QNX. I haven't got to use it for anything else, but it saved our bacon on this job. So yeah, this was an interesting project. The good side of the project was they were up against a really tight time scale because they had just pissed away 2 years of time that they had to get this thing going. They already had an uplink running in the US and they needed to bring it to the UK, and they had just failed. They'd just failed to do it. So their vendors were saying to them, oh, you need bigger tin, you need more, processing power. And I was called into this meeting because they had, they'd bought CD Grab in order to grab the music, and they'd told me what the project was, and we'd had a chat about it, and he'd explained they're doing this thing with 64 channels. And I was like, wow, that's a lot of data. Are you sure you're going to be able to push that through a single server? And he's like, yeah, no, the vendors assure us it's going to be fine. So he called me to the meeting, and this was like, a few days later, this was the sign-off meeting where they were about to hand this vendor a check for like millions of pounds to provide all this hardware. And this was just the, meet and greet and everyone smile and here's your check and let's get going. And so I went to this meeting and I drew a little diagram on the whiteboard, and I'm like, okay, so here's your server with its 1 10 megabit network port, and here's your uplink, and you're going to do, what is the number? 75 frames a second of 232,352 bytes. That's 176K per channel, K bytes per channel. And you got 64 of those. So basically, you need 128 megabytes of data to go through this system. In those days, that was a seriously big deal. Okay, we had 10 megabit networking at this point. So they put the check back in their pocket, and they left the meeting, and the vendor was very unhappy. And they said to us, help, what do we do? So anyway, we got the project, and because they were so desperate, and it was a big, conglomerate of multinationals, they had a lot of cash, and they were just like, just do whatever it takes, spend the money, get it done. So we were just buying equipment and testing it. We didn't have to scope anything. We were just like, well, maybe that will work. Right, buy one, get it here, let's test it. So that was quite fun. The other thing that came out of that is we needed a programming team that worked on a big project in a very short time span. And so this is where, again, this is before the internet and before, that level of communication was common. We actually had teams all over the world. So we had a team in Australia, we had a team in the US, and we had a team in the UK. And so we were able to work around the clock, 24/7 on this project, and we had like shared code repositories and so on. And again, this is before GitHub and so on. So this all had to be kind of invented on the fly. How do we do all this stuff? But it was great, to see that evolve and to get that kind of process working. So the bad side of this was nothing actually worked as advertised. The manufacturers of the network switch, again, this was a big deal at the time. We found someone who had a 128 port, 10 megabit switch, and they claimed that you could absolutely, you could push the full 10 meg through all 128 ports all the time and it would just work, no problem. That was a lie. the thing crashed as soon as we actually had more than about 20 channels going. And it turned out that all the testing they had done was to do with number of packets. So they were sending packets. We could never get them to tell us, well, how big were those packets? We can do a quick bit of maths and work out how much you're pushing through this switch. But all of the tests they'd ever done and all of the proofs they had for their performance were to do with numbers of packets, not actual data throughput. So that was painful. It was a very, very, very expensive switch, and they basically had to shut down manufacture of the switch and redesign all their VLSI chips and so on to make it work. The other thing was we had CD jukeboxes. Each jukebox had 4 players in it. So we were ripping CDs. This is kind of funny. We were ripping CDs, but because of the cost of hard disks, we were then burning them back to data CDs. So you had a music CD that was converted, the exact same music, back onto a data CD as files instead of a Redbook audio. But we then had these jukeboxes, which had 500 discs in each jukebox and 4 players. And again, it didn't work as advertised. It turned out that every time you sent a SCSI command to the device, it would have a 10-second pause while it thought about it, which was not good. And then what came out of that was, of course, the vendors just tried to blame us and say, well, it must be their software, it must be, our equipment works, it's not our fault. And so we then had to get into these really ugly showdowns where we're like, no, we're now going to prove that what you're saying is rubbish. And so they would bring in their poor developer who would sit there, and we would have to humiliate the guy and say, look, this is what he did wrong. And so, yeah, that wasn't pleasant, but that's the way they played the game. Then the internets came along. So we published this bit of software called Apache SSL, which was the first secure web server software. And at the time, again, kind of hard to believe, but it was considered, strong crypto was considered a munition of war. So basically, taking strong cryptography, by the US anyway, taking strong cryptography across the border, in or out of the US, was like taking a nuclear weapon across the border. And I don't know if any of you remember, do you remember the T-shirts that say it's just an algorithm? Yeah, so we used to wear shirts with the algorithm on it and cross the border as a joke, going, look at me, I'm taking a munition of war across the border. But it was a serious thing. They didn't want strong crypto to be exported out of the US, which is why Apache didn't have strong crypto in it in the first place, because they weren't allowed to. So they published Apache with modules, so you could plug in a module. So we wrote the SSL module for Apache. And then we went to the British government and we said, so what's the deal? I mean, if the US don't allow it to be exported from there, is there a problem with us exporting it to them, or generally? And I think it was the Department of Trade and Industry, and they said, well, we don't know. We can't give you a definite answer on that, but for now it's fine. Just keep track of everyone who downloads it. And we're like, really? How do you do that? And what happens if you suddenly decide it is bad? So luckily for us, I mean, we did start distributing it ourselves. We just set up an FTP server, and we're like, well, we'll keep the logs. We can tell you what IP downloaded it, and that they logged in as FTP, password anonymous. But can't tell you who they are. So anyway, Oxford, I think Cambridge University came along and said, okay, well, why don't we put it on our servers? And then if there's any problem with anyone saying you're not allowed to export this stuff, then that'll be a good, useful training exercise for our law students. And we'll just give it to them and they'll defend you. And we're like, cool. And then Oxford came along and said, oh, okay, well, if Cambridge are doing that, we'll do that too. So you can put it on our servers too. So in the end, we had Oxford University and Cambridge University doing the distribution for us, and the nice cozy umbrella of their legal departments saying they would defend us in the case it all went horribly wrong, which was lovely. And we got squillions of downloads, and it became huge, and we had 70% of the world market for secure web servers. And again, you know, Microsoft and the rest of the world had the share of 30%. And actually, again, I don't know how many of you remember, but Microsoft were actually quite late to enter the internet market. They believed that their network, so MSNet or something, was going to be the thing, and the internet was just a passing fad. They refused to even put TCP into the Windows stack for years. So, you know, it was kind of weird to see that Windows, you had to buy plugins to actually connect to the internet. But anyway, we did all that, and it was huge, and we were, you know, shipping squillions of copies, but it was open source and it was free. So, yeah, we didn't become millionaires overnight, sadly. But what we did do is get a lot of interesting work from it. So, the first bank to go online came to us, and they were Scottish Bank. And that picture, the lady on the left is Amanda Lamb, who was the face of the bank. And she was this very modest, you know, wearing a shawl. It was called Scottish Widows. So she was like the Scottish widow, and it was all very modest. She was on lots of TV ads, and she was very famous for doing it. And then for some reason, she decided to do a bikini shot. Don't know why. I mean, it wasn't porn. She wasn't naked, but it was a bikini shot. And she got in a lot of trouble for it, and I think she actually got sacked, so they didn't use her anymore. But at the time, we had a continuous paper printer, and we managed to get a high-resolution picture of it. And so I printed a full-size picture of her in the bikini, and I took it to the Scottish Widows headquarters, and in their main server room on the back of the door was this full-size picture of Amanda. And we always used to say, you know, we're going to Amanda's if we had to go to the data center. And we just thought it was funny that none of the bosses who had sacked her knew that they had the bikini shot in their server room downstairs. I don't have that picture anymore, but when I was trying to find it for this slide, just don't search for silver bikini on the internet. Some things can't be unseen. Okay. And the other one we did that was really interesting was the first telco to go online. So one of the really big networks in the UK decided to have a look at this funny internet thingy, and they started a project. And what happened was really surprising to everyone. I think in a period of 2 years when we worked on the project, the guy who had basically had to be strong-armed into doing it because everyone thought it was a dead end. And like, he thought he was committing, you know, business suicide by going into this department who was going to do this silly little internet project. It became more important than any other business that phone company was doing. And he ended up as the head of the company. So he ended up taking over the entire telco. So that was really interesting. And that happened over 2 years. You know, he went from just being a management guy to being the boss. So that's how important the internet had become. Who knew? And then because we were getting all of these jobs, and we were being asked, well, now you've created this, and security had always been a thing for us because, you know, we'd seen it all grow from the ground up. So we were used to having to look under the hood at everything we were working with. And so we had always focused on security. And that's why people like banks and telcos talk to us, because, you know, we could do it properly. So we started looking at, when we were looking at other customers who didn't have their own mainframe server rooms already and data centers of their own, we're like, well, where can we put our projects? When we do a project for someone, where can we put the servers? Because if I just go and put it in a shared hosting facility, that's not going to be very secure. So we bought an underground nuclear bunker, which had just been refurbished by the RAF. It used to be the Radar Command and Control Centre, part of the UK National Defences, and they decided it was surplus to requirements, and they sold it off. But because it was secret, no one knew they were selling it off. But I knew. So I got it really cheap. So we got this bunker for super cheap, and we set up a business in there. And we're like, wow, this is so cool. We've got our own secret underground lair. So what we can do is we can be really proactive, and we can monitor threats, and we'll test them all and make sure that, you know, each threat actually works and that we're defended against it and so on. And so we did, and we started doing secure hosting. How much time have I got left, by the way? 5 minutes. Wow, I do ramble on. Sorry. But yeah, that didn't seem to stop him. I was amazed at how much. I mean, again, now this is all common knowledge, but we were just amazed at how fast, if you put a server online, within seconds, we would be under attack. It was just incredible. So we found out blue teaming is hard. You have to get it right 100% of the time, but the attacker only has to get it right once, obviously. So I'm like, I know, I'll change sides. So I'm going to go on the attack. So red teaming for me. But what am I going to do? I was kind of bored with networking stuff. You know, I've been doing it for over 10 years, and it was getting a bit dull. So I decided hardware was the way to go. It's the new frontier. So basically, a lot of stuff over the years has been tucked away in hardware. It hides a lot of sins. Embedded systems, you know, they tend to be kind of modular, so different people make the different bits, and they all plug together to do something. And so there's a lot of issues potentially with where those things join together and where the modules talk to each other. They're very often made by third parties who then don't maintain them anymore. You know, once you've built an embedded system, it's very unusual that you will then go back and start updating the individual components within it. So you can end up with stuff out there in the millions that's never going to get updated, has got lots of problems, and all you have to do is find them. And when you find a problem in a module, you'll find that module in a bunch of other things as well. So it was really rich pickings. And people sell them and move on and do something else, and they white label it, and it keeps getting sold and sold and sold. So some of the interesting things we found, 3 chips within a single chip. So I don't know if you can properly see it here, but if you look, there's a little chip on the right, and then there's another big chip in the middle, and then there's another little chip on the left. And on the outside, this just looks like a single chip. So it's only when you X-ray it that you find, actually, there's 3 chips in there. One of them was an EEPROM, one of them was an MCU, and one of them was an RF transmitter. So, what's that doing? So that was interesting. We built some equipment for drilling down into the chips using fuming nitric acid. So we could very accurately drill a little hole. I mean, this picture's actually from something that's been decapped, but we could also just drill little holes and expose the bond wires. So you can then tap in and watch the conversation. So on that particular, the 3-chip, we drilled down to the wires between the EEPROM and the MCU, and then we were able to watch the conversation going on between the EEPROM and the MCU. So the data that the manufacturer thought they had kept entirely secret, there were no pins on the outside of this chip that gave you access to the EEPROM, but there were obviously pins inside that gave the MCU access to the EEPROM. And so the hardware guys thought, well, it's hidden in a block of silicon. You can't get to that. We don't need to do anything secure here. So all the data going between the EEPROM and the MCU was in plain text, non-obfuscated, so we were able to extract secret keys from that EEPROM. We then dissolved the whole chip in acid, cleaned it up a bit, and that's the masked ROM. So in the masked ROM, you can actually see the code. So basically, a dot or an absence of a dot is a bit. So it's either a 1 or a 0. So you can actually just take that, turn it back into a binary, disassemble that, and you've now got the source code, or decompile it after you disassemble it, and you've now got the source code for the device you're looking at. So that was pretty awesome. We managed to completely reverse that entire system. And again, not particularly uncommon these days. There's a lot of old hardware out there that's behaving in the same way. So finally, as I say, I'm just kind of rambling on about how I got here. I didn't expect to get here. I left school at 14 with no education at all. There's a joke in our industry that if you were a criminal, you'd be a lot better off because it's too easy. I mean, seriously, if we were doing this as criminals, we would all be rich and lying on a beach somewhere. Oh, wait, I am at a beach somewhere. So, yeah, I mean, I just wanted to say, you know, I meet a lot of people in this industry who didn't know they were going to get into doing what they're doing. They just kind of stumbled into it, which is what happened to me. But yeah, keep on hacking. Thank you. Do we have time for any questions? Any questions? Got one over here.
Thanks, Adam, for the presentation. Real quick question regarding the silicon chips. How applicable are those today?
How common are the chips today?
The technique that you did to drill down to the silicon chips and read them.
It's still very effective. I mean, tapping onto bond wires applies to pretty much any chip that's out there now. The equipment to do it is quite expensive if you buy it. I mean, I think you can buy a machine that will do that kind of drilling for about 20 grand. We built one for a couple of £100. You know, my hardware partner, Zach, is very good at that kind of stuff. And he invented his own machine we called the decapinator. I wouldn't go near it personally because it's dangerous. Fuming nitric acid will kill you. So you have to be careful, but it can be done, yeah. And cool. I think it's very relevant still, yes.
Thanks.
Anything else? No, I think everyone's leaving anyway, but thanks again. Cheers.